Okay, students, so after Rolle's theorem, we have Lagrange mean value theorem, or you can just call it a mean value theorem. So, what were the conditions in Rolle's theorem? Let's see once again. The function should be continuous on the closed interval and it should be differentiable in an open interval AB. And third condition was fh is equal to fb. So these three conditions were there. So what is our conclusion? That there will be some point C where the derivative will be 0. So geometrically you can see uh, this function is smooth, and the function value at initial point and final point is same. Then there will be some point in between where the tangent is horizontal. Okay, that is the geometrical interpretation we saw in this diagram. Now in the Lagrange mean value theorem, we will drop this third condition that function value should be same. Okay, but then of course we will have different conclusion. So let me tell you once again what is Lagrange mean value theorem. So you drop the third point. Okay, so function is continuous on closed interval and it is differentiable on open interval AB. Then there exists some point C such that derivative is not 0, however it is equal to fb minus fa upon b minus a. Okay, so it is the generalization of Rolle's theorem. यानी कि अगर तुम देखो कि एफ बी इक्वल टू एफ ए है तो ऑफ कोर्स ये ज़ीरो हो जाएगा. ओके, दिस लेफ्ट हैंड साइड विल बी ज़ीरो. Now what is this part? fb minus fa upon b minus a. So something like it is y upon x. Okay, and y upon x is tan theta, because this function values are on y axis and this domain values are on x axis. Okay, so it is some sense slope of a line, and this is a slope of a tangent, right hand side. So slope of tangent is same as that of slope of line. And what is this line? It is a line joining the points a comma fa in the graph and b comma fb. Okay, and what are those points? Those are initial and final points on the graph. So that is the what we have geometrical interpretation here. देखो ये तो कोई function है, and you can see that fa is not equal to fb. They are not on the same level. Okay, so this point b has coordinates b comma fb. Okay, and this point a has coordinates a comma fa. Okay, now line joining two points equation की होंदी है. Okay, so equation of the line joining a comma fa, equation नहीं आप कहते slope कहते हैं. Slope of the line joining a comma fa and b comma fb की होंदी है y2 minus y1. y2 is fb, y1 is fa upon x2 minus x1, fb minus fa upon b minus a. So आ जो लाइन है कैपिटल ए एंड कैपिटल बी ਨੂੰ ज्वाइन कर दी हुई, ਇਹਦਾ स्लोप है दिस लाइन द स्लोप की है fb minus fa upon b minus a, which is our left hand side in the Lagrange theorem. और राइट हैंड साइड थे एफ डैश सी, यानी कि देयर विल बी सम पॉइंट सी जिथे कि वो लाइन द स्लोप टेंजेंट द स्लोप जो होएगा वो इक्वल होएगा, यानी कि टेंजेंट विल बी पैरेलल टू द लाइन जॉइनिंग ए एंड बी. ओके, सो व्हाट इज द ज्योमेट्रिकल इंटरप्रिटेशन? टेंजेंट एट सम पॉइंट is parallel to the line joining capital A, which is A comma fa, and B, which is small b comma f. Okay, that is what Lagrange theorem means. Lagrange mean value theorem. So that is what written here. Slope of the line AB is fb minus fa upon b minus a, and so graph is continuous. It is there is a unique tangent. It means there is some point where the tangent is parallel to the line joining A and B. Okay. So second, now this should not be a same point, uh, unique point. Okay. As you can see in second diagram, there are three such points C1, C2 and C3 where the tangents are parallel to this line joining A and B. Okay. So C may or may not be unique. So what is the physical interpretation? Physical interpretation means if a particle is moving in the straight line and there are Fa and Fb are positions of the particle at time A and time B, then the average speed of the particle is Fb minus Fa upon B minus A, and instantaneous speed की होती है F dash C. So physical interpretation की है कि at some point the instantaneous speed will be equal to the average speed. Okay, that is all. You must have seen in physics course as well this rule. So Lagrange mean value theorem tells you कि ਇਹਦਾ ਮਤਲਬ ਕੀ ਹੈ, ਇੱਕ ਸਿੱਧੀ ਜਿਹੀ ਭਾਸ਼ਾ ਦੱਸਾਂ ਕਿ ਅਗਰ ਤੁਸੀਂ ਇੱਥੋਂ ਤੁਸੀਂ ਚੰਡੀਗੜ੍ਹ ਗਏ ਹੋ, ਓਕੇ, ਤੁਹਾਡੀ ਐਵਰੇਜ ਸਪੀਡ ਰਹਿੰਦੀ ਹੈ 70 ਕਿਲੋਮੀਟਰ ਪਰ ਆਰ, ਤਾਂ ਤੁਸੀਂ ਕਦੇ 60 ਤੇ ਜਾਂਦੇ ਹੋ, ਕਦੇ 80 ਤੇ ਜਾਂਦੇ ਹੋ, ਕਦੇ 110 ਤੇ ਵੀ ਜਾਂਦੇ ਹੋ. ਓਕੇ, ਅਤੇ ਇੱਕ ਨਾ ਇੱਕ ਮੂਮੈਂਟ ਇੱਦਾਂ ਦਾ ਆਏਗਾ ਜਦੋਂ ਤੁਹਾਡੀ ਐਕਚੁਅਲ ਸਪੀਡ ਤੁਹਾਡੀ ਐਵਰੇਜ ਸਪੀਡ ਦੇ ਇਕੁਅਲ ਹੋਏਗੀ. ਓਕੇ, ਇੰਸਟੈਂਟੇਨੀਅਸ ਸਪੀਡ, ਯਾਨੀ ਕਿ there will be some point where you are driving at 70 kilometer per hour. Okay, which is trivial as you can see from the practical example, but theoretically the Lagrange mean value theorem gives you the proof. Okay, so the examples are similar, you can solve them. For example, first question, discuss the applicability of Lagrange mean value theorem. So what you have to do here, first make it in a polynomial form. Okay, since we know every polynomial is continuous, so the first point is valid. A function is continuous in a closed interval. Derivative is also again a polynomial, so derivative exists at every point between the open interval 0 and a half, and thus no need to there is no third condition, so both the conditions are satisfied, thus Lagrange mean value theorem is applicable. So there exists some point C such that this slopes are same, and from here you can find the value of C. Okay, so C is coming out to be there. This is a quadratic equation in C, so it will give you two values, 1.76 and 0.24. Now 1.76 does not lie in 0 to half, so you will choose 0.24. Okay, 0.24. So at that point the tangent will be parallel to the line joining FB and FA. Okay, similarly, second example, sin x plus cos x, these are always continuous, and you can easily calculate C. Okay, so in this case C is coming to be 1 minus C exactly you cannot solve from here, just keep in mind sin 2C आया ना अपने को, 1 minus 16 pi square, so 2C will lie between 0 to pi by 2, because at pi by 2 sin theta is 1. Now this right hand side quantity is less than 1, and from 0 to pi by 2 sine is increasing function. Okay, so at pi by 2 sine is 1 and it is an increasing function, so C lies somewhere here. because value of sine 2c is coming to be less than 1. Okay, so it lies between 0 and pi by 2. We are not getting here the exact value of c, but we are sure that it lies between 0 and pi by 2. Okay, so next is we have a parabola y is equal to x minus 3 square, and again you can easily solve this question. So here you have to find where the tangent is parallel to the chord joining 3 0 and 4 1. So what you are given here is 3 0, यानी कि a is given to be 3 and f of a is given to be 1. Similarly b is given 4 and f of b is given to be 1. So if you can see that chord is horizontal, okay, so tangent should be, slope should be 0. Parallel to the chord 3 0 है, okay, 3 0 है, okay, so derivative should be 1 not 0. Okay, uh, okay, so it is easy to calculate. You can find that. Okay, c तो ਤੁਹਾਨੂੰ ਪਤਾ ਲੱਗ ਜਾਏਗਾ ਨਾ, c ਤੁਹਾਡਾ ਆ ਗਿਆ 7/2. okay, now 7/2 ਤੇ y ਦੀ ਵੈਲਿਊ, so x is 7/2 and y ਆ ਜਾਏਗਾ 7/2 minus 3 whole square. So this point is the point on the graph where the tangent is parallel to the chord. Okay, so similar questions, example 4 is also similar. Then you have 5m exercise. Just so you need to solve all, and please ask me if you have any doubt. You must solve all these questions, especially the last 10 to 20 questions. Okay, these are important questions. These are the answer. Okay, so with this the differentiability chapter is done, and we will now have second next chapter, which is applications of derivative. Okay, ठीक, so we will do that later on. First of all, you are needed to complete this Rolle's theorem as well as Lagrange mean value theorem. So there are many questions, miscellaneous exercises and all that. You can solve any all the questions from this book. Okay, and tomorrow I will tell you about applications of derivative, why derivatives are important. There are many real life applications as well, and this quote is also very beautiful. There is no permanent place in the world of ugly mathematics. Okay, so all we are doing is a beautiful mathematics, since Newton has discovered most of the things of calculus, and Newton was in 16th century, 17th century, and from last 350 years we are trying to understand all the calculus. Okay, so it's a beautiful mathematics. Thank you very much.